All right. So 1.7 day 2. We're still with our absolute values, all right? But we're no longer equations. It's your inequalities there. Now, inequalities it's a big thing because it's more about what you see out there in the world, where there's lots of things that will work rather than just simply only one particular number that's there. So let's jump into it and let's see what we got going on here. How many solutions still? Yeah, that's part of the conversation that's there. Yeah, remember, we're going to be dealing with two solutions, so writing out those two equations. So we're still going to isolate the absolute value, all right? We're still going to do that. We're still going to write our two equations, just like we did before. But now, after we solve them, we're going to have to be checking intervals. And we've done this a little bit, but now you're really going to see it in place. Like, we had and statements, we had or statements, and then we had a few sprinkling of problems where they didn't tell us either of them, and we had to start checking them. Okay, so this is really where you're focusing in on the critical values as your starting points. We're going to have to then finish off your graph based by checking things, and then finally write your solution interval notation. People, there's a lot, all right? There's a lot to do here with these problems, but they're gonna be very sequential, and that's what we're about now in Algebra 1. It's not just like, hey, one and done, all right? We've got multi-steps in interpretation to do here. So we're gonna kind of leave it up there so we can see it, and let's go into it. So isolate the absolute value. Question 1, it's already isolated. So, okay, check that off the list. We are ready to write our two equations. So, yeah, x minus 1. All right. And we're really just kind of looking at your normal solving equation skills. Now, I know we see the inequality there, but listen, you're working it like this and you're working it like that. And I know you might think, whoa, you just switched it. We did, because we're doing this to find the critical points. We'll use that absolute value symbol, but this gets us the critical points. So we're going to add 1 to both sides. X equals 4. Still add 1 to both sides, but this time x is going to equal negative 2. All right. So we've taken care of b. We've solved the equations. Now, check your intervals by using the solutions. In other words, the critical values as your starting point. So I've got a negative 2, and I've got myself a 4 that's there. All right. Now, I do see that I've got or equal to symbol, all right? So that tells me that, okay, yeah, we're going to be shaded, all right? We are going to be shaded there. So that's definitely a piece that's there. But now we got to check and see who works. So we're going to grab the original problem and plug numbers in. So I'm going to start off to the way right and over here and check like someone like 100. I like to go excessive, because I feel like I can, visualize it better. So 100 minus 1, 99, absolute value of 99, 99. Is 99 greater than or equal to 3? Yes, it is. So that gets the check as in, hey, we are good to go over there. That will get us some winning answers. Let's check between -2 and 4. Well, yeah, if I can use 0, I'm going to use 0. So again, I'm going to plug it in. 0 minus 1, all right. Absolute value, is that greater than or equal to 3? Well, 0 minus 1 is -1, but the absolute value of -1 is a positive 1. Is 1 greater than or equal to 3? No. So no, thank you, that's there. Now we're going to check to the left of it of -2. So yeah, again, I'm thinking like -100 that's there. Again, I just see it easier. -100 minus 1. All right, and then, okay, and then take the absolute value of it. All right, so that's 101. Is 101 greater than or equal to 3? Yes, it is. So there we go. So I know I'm here, and it keeps going. I know I'm here, and it keeps going. Now we're going to write it in interval notation. So remember, interval notation, we start with the smallest number, and then we work our way across to the largest number, so left to right. So I've got a negative infinity that's going to -2, Can't land on it, so you get parentheses. Infinity always gets parentheses. I got a shaded in circle because of my or equal to statements, so you get a bracket. All right, I've got my union symbol, and again, I'm using my for. It's going all the way out to positive infinity. Can't land on it. You get the parentheses. Shaded in circle, again, because of the inequality, you get the bracket. And we're done. All right, so still making your two equations, getting those critical values down, and then we're testing it, all right? And we did see that a little bit, but now we're going to be much more formal with what we're doing. So let's go to problem number 3, all right? So in problem number, two, and we're going to show why here, because we're going to see a trend now with it, and it's something I want you to watch for. So like when you look at problem number 1, do you see how it's a greater symbol? Greater than equal to, but greater or statement. All right. Yes, this is going to be a thing with your inequalities. Now, especially with your absolute values, when we go back and we look at the other ones, it depends how the problem's kind of structured, so we really don't use that, but this is something that works with inequalities. And then less than, and less than, yes, less than, get ready, this is going to end up being an and statement. Now, it's still going to happen all by itself, but it's something to kind of be aware of where you're like, okay, I know the path we should be going down, and we should end up seeing it. So let's jump on in. We're isolated, all right? So let's just make the two, 4x equals 20, and let's get the 4x equals the negative 20. Divide both sides by 4, yep, x equals 5. Divide by 4, yep, x equals negative 5. All right, so I've got my critical points. I got my negative 5, I got my 5, that's there. Or equal to's, so I know that we're going to be shaded in, all right? Now let's test some points. So again, I'm going to grab someone like 100, all right? Plug it on in. 4 times 100, 400. Is 400, all right, less than or equal to 20? No, 400 is not less than or equal to 20. Didn't work. Who's between negative 5 and 5? I told you, if I can use 0, I am using 0. So let's plug in 0. 4 times 0, 0. Absolute value of 0, 0. Is 0 less than or equal to 20? Yes. So I know that we've got working there. And again, we should alternate, which tells me if I test out negative 100, it should fail because I'm actually going to be in a similar situation. Look at that. That 4 times negative 100 is negative 400. What's the absolute value of negative 400? It's 400 right there. We've already got it, and it's a no that's there. So here we go. So we have an idea. Now, we still should be testing. And I don't want you to jump to the conclusion that because it's an and statement, just push them together. It's an or statement. We should be going out to side. It's something to be aware of. But again, we're ready not, you don't want to just jump into it, and say, oh, that's what we're going to do every single time. All right, let's go to the next page. And let's find someone like problem number... Let's find problem 4, okay? In problem number 4, we do have to isolate first. So we are going to have to add that 3 on over. But now we've got the symbol isolated. 7 plus 3 is 10. As poorly as that 3 is written, it's still a 10. Now we're ready to write our two equations out. Okay, so x plus 2 equals 10. And then the x plus 2 equals the negative 10. So again, it's absolute value. You've got to make those two equations. And again, we just change it. We make the one positive into the negative there. So subtract your 2, and yep, we get an 8. Subtract your 2, and we get a negative 12. All right. So now we're ready to put our critical points down. I got me a negative 12. I got me a positive 8. All right. Now, when it comes to plugging it in, you can go to the original. That's fine. It's going to work. You can also go to your cleaned up version. Now, your cleaned up version is going to be faster. And so I would encourage that because you don't have to do that additional step that you're looking at of always then subtracting the 3, then comparing it. So I'm always going to use my rewritten one, my cleaned up version. So I'm going to try again. I'm going to try something like 100. 100 plus 2, 102. Absolute value is still 102. Is 102 less than 10? No, 102. 102 less than 10? No, it's not. So I'm thinking, Now, I did see here that is a less than, get it? Less than. You see, okay, you caught it before. I'm sorry if I keep pushing that home there. But yeah, no thank you, that's there, all right? Let's try someone in the middle. All right, our good friend 0. One's negative, one's positive. I'm trying 0, all right? So 0 plus 2, 2. Absolute value of 2, still 2. Is 2 less than 10? All right, so yep, that's good, which means it should fail out here. Negative 100 plus 2, negative 98. The absolute value of negative 98 is a positive 98. 98, is that less than 10? No, it's not. So just the less than symbol, open circles, and there we go, right in between. There we go. So now we're ready for that interval notation, all right? So I go as small as negative 12. I go as big as 8. Wrap that in parentheses. I feel like I forgot to do interval notation on the previous one. Is that the case? I did, didn't I? Yes. Okay, let's get this one here. All right, kind of throw that in there. Yeah, it's negative 5 to 5, and it's brackets. All right. Test-wise, we'll lay it out for you. I won't tell you like do 3 things and then we'll have answer blanks because I get it. It's easy to skip over it. I mean, my goodness, the amount of times that I've been doing that. So, all right. Now, this last part that we're getting into is the opposites. Now they're giving us the graph, and we want to write out the absolute value function. So we're kind of putting in reverse here, all right? So here's how this works. To write it out, you need to find the midpoint. And the midpoint, that's exactly what it says, it's the point that's in the middle. So we look at how far we have to go, all right? We travel a total distance of 16. Because I got 0, and that's 4, and then that's 12. So entire distance is 16. So entire distance is 16. The midpoint, that means it's going to be 8 and 8. So if I go 8 away, we should be at a 4. And sure enough, if I go 8 away from negative 4, we land on a 4. So what you do is you always write its opposite in the absolute value. Opposite. It's a 4. That's why I put down x minus 4. And then the distance between the original points and the midpoint is the answer to the inequality. The distance between the original points, like 12, and the midpoint. How far is it from 4 to 12? It's 8. All right. And again, we kind of established there. So that's who ends up going out here. So yeah, it's a distance. It's going to be positive. All right. And now this is where we're like, oh, it went together. So that is a and statement, which means it's a less than. All right. And that's there. So less than or equal to. And again, I'm shaded in. So that's why we got the line that's underneath there. All right. Let's do one more that we're looking at. All right. From 2 to 6, it's a distance of 4. So the midway point would have to be 2 and 2. All right. Which tells me 4 is the middle. Opposite. So yep, it's x minus 4. You're inside the absolute value bars. The distance from the midpoint and the end, that's a 2. All right. I'm going the opposite ways, which that means there ain't no overlap. So that is an or statement. So that is a greater. I don't have my circle shaded in, so that's why it's just staying like that. All right. The very last one that you see there at the bottom here, or actually, no, we're just going to focus on this last one. Distance from negative 3 to 11. Ooh, that's an 8, which means I got to travel 4 and 4. So if I'm at negative 3 and I move down 4, all right, that's 7, but that's a negative 7. Remember, the opposite, so you get that. All right. The distance, it's 4 away, and it's a less than because there need to be overlap, and we're just open. That's there. That's it. We'll see you.